type 4 category formulas. 1. Integral sin x dx is minus cos x plus c. Integral cos x dx is sin x plus c. Integral secant square x dx tan x plus c. And integral cosecant square x dx equal to minus cot x plus c. Observe this, differentiation of cos x is actually minus sin x. So integration of sin x gives you minus cos x. Same way, differentiation of sin x gives you cos x. No? So integration of cos x gives you sin x, because integration is the reverse process of differentiation, and this is by integration by decomposition method no. So the results are directly from the differentiation part. So now integral sin ax plus b into dx is actually integral sin x is minus cos x no. So minus 1 by a cos ax plus b plus c. Coefficient of x is a. So write minus 1 by a, which is nothing but of cos ax plus b and minus cos ax plus b, and the differentiation of ax plus b is actually a, that you are supposed to write in denominator. Integration of cos ax plus b into dx. Integral cos x gives you sin x. So this is actually sin ax plus b, and write that coefficient of x 1 by a. Okay. Integral secant square ax plus b into dx is actually 1 by a tan ax plus b plus c. Integral cosecant square ax plus b into dx is actually minus 1 by a cot ax plus b plus c. Today we do problems based on this formulas. So first problem, integrate with respect to x. Integral 2 sin x minus 5 cos x into dx. Now take this integral separately for each term. Integral 2 sin x, well dx multiply with each term, you will get minus integral 5 cos x into dx. Take the constant outside the integral sign. Sin x dx minus 5 integral cos x dx, and integral sin x formula. So if you forget means, okay, just try to recall what is the differentiation of cos x minus sin x. So integral sin x gives me minus cos x plus c. So this is actually minus cos x. No need to write plus c over here. After completion of remaining integral portion, you can at last write plus c once. So integral cos x is actually, so what is differentiation of sin x cos x no? So integration of cos x gives you sin x plus c. So this is sin x. So our integral part is over in this expression no? So just write plus c over here. This is minus 2 cos x minus 5 sin x plus c. Okay. So next problem, second one, integral 2 cos x minus 3 sin x plus 4 secant square x minus 5 cosecant square x into dx. Now take this integral separately for each term. Dx minus 3 sin x dx plus 4 secant square x dx minus integral 5 cosecant square x dx. Now take this constant outside the integral sign. Cos x dx minus 3 integral sin x dx plus 4 integral secant square x dx minus 5 integral cosecant square x dx. Now just apply the formula what I gave you. So integral cos x sin x, integral sin x minus cos x plus 4 tan x minus 5 minus cot x plus c. So 2 sin x plus 3 cos x plus 4 tan x plus 5 cot x plus c. Okay. So next problem. Third one. What is integral root of 1 plus sine 2x into dx? So this is trigonometric function of sine 2x and all. So where are the trigonometric function places you feel difficult to approach the problem, if you have one here means you can use this formula sine square x plus cos square x, use this identity equal to 1. So instead of this 1 I am going to use this identity. So I will get integral root of sine square x plus cos square x plus sine 2x. So sine 2x into dx. So sine 2x formula is actually sine square x cos square x. Sine 2x formula is 2 sin x cos x. Okay, sine 2x is actually 2 sin x cos x. So use this over here. This is not a new one for us. This is actually a is sin x, b is cos x. So this is a square b square plus 2ab. So this is actually sin x plus cos x the whole square into dx. Okay, just to cancel this you will get integral sin x plus cos x into dx. Now this is integral sin x dx plus integral cos x dx, which gives you integral sin x is minus cos x, integral cos x is sin x plus c. Okay, take one more problem as homework in the same way. What is the solution for integral 1 minus sin 2x into dx? Take this problem as homework. This is same as the previous one. Instead of 1 you can express this as sin square x plus cos square x, and here you will have minus sin 2x, you can write that as 2 sin x cos x. No, here you will have minus. So this will become a square plus b square minus 2ab. That means sin x minus cos x the whole square you will get. Definitely you will have minus over here and you will get negative sign over here. Okay. So next problem. Fifth one, integral 1 by sine square x cos square x into dx. So here also I am having trigonometric function in the denominator. So to get my integrand in much more simpler way, I am going to write sine square x plus cos square x in the place of 1 divided by sine square x into cos square x into dx. So now write this as sine square x divided by sine square x cos square x plus cos square x divided by sine square x cos square x into dx. If you cancel this, you will get 1 by cos square x plus 1 by sine square x into dx. So this is actually 1 by cos square x is secant square x, 1 by sine square x is cosecant square x into dx. Now take this integral sign separately for each term. Secant square x dx plus integral cosecant square x dx. So this is tan x minus cot x plus c. Okay. So now seventh problem. Before going to the seventh problem, I give you 3 different formulas for cos 2x. Note it down. Cos 2x can be written as 1 minus 2 sine square x cos 2x can be written as 2 cos square x minus 1 cos 2x can be written as cos square x minus sine square x. These three formulas are very much important. Okay, so now seventh problem, integral cos 2x plus 2 sine square x divided by cos square x into dx. So in the place of cos 2x, I can use any one among this formula, this three. I'm going to use right now is this. You can also use this one. It will be easy for you to use this one also, and if you use this also, you will get the same answer. Okay, so any one among these three. So in the place of cos 2x, I am going to write this means cos square x minus sine square x plus 2 sine square x divided by cos square x into dx. So this is actually cos square x minus sine square plus 2 sine square x gives me sine square x divided by cos square x into dx. Okay, so this gives me plus sine square x. If I rewrite this as this way, so I will get this get cancel, integral 1 plus, and this gives me sine square x by cos square x, that is nothing but of tan square x into dx. So 1 plus tan square x is actually secant square x, no? So into dx, this gives me tan x plus c. If you use this one, you directly get the solution. Why? Because in the place of cos 2x, you will write 1 minus 2 sine square x, no? So minus 2 sine square x plus 2 sine square get cancelled. 1 by cos square is actually secant square x. While integrating this, you will get tan square x. So this gives you easily solution for this integral. I used this one here. You can do the same problem by using this one also. Now, eighth problem. So, integral sine square x into dx. Okay. So, integral sine square x dx means definitely you think of this formula cos square x equal to 1, so that in the place of sine square x I can write 1 minus cos square x. Don't use this formula. Whenever we have a higher power for a trigonometric function, no, it is difficult for us to do integration. If you use this one, no, again you will get higher power for the cos function. So don't use this identity if you don't want higher powers of trigonometric function. So I have cos 2x, no, one formula 1 minus 2 sine square x. So I am going to rewrite this as 2 sine square x equal to 1 minus cos 2x. Okay, I am taking this to the left hand side, that to the right hand side. So sine square x can be rewritten as 1 minus cos 2x divided by 2. So this can be written as 1 minus cos 2x divided by 2 into dx. Okay, so take this 1 by 2 outside. You will get integral 1 minus cos 2x into dx. 1 by 2 integral dx minus integral cos 2x dx. Okay, now this is 1 by 2. Integration of dx gives you x minus. So integral cos ax plus b into dx gives you integral cos x is actually sin x. So 1 by a sin ax plus b plus c. So here also this is coefficient of x here is a, and here coefficient of x is 2, no, 1 by 2 sin 2x plus c. Okay, if you multiply this 2, you will get x by 2 minus sin 2x by 4 plus c. Okay. So now integral cos 2x divided by sin square x cos square x into dx. So here cos 2x, I'm going to use this formula, cos square x minus sin square x divided by sin square x into cos square x into dx. So again, if you partially take this, we done this problem already. Okay, so now ninth problem, integral cos cube x into dx. Okay, you want to find integral cos cube x and dx into dx. I give you cos 3x formula. Cos 3x formula is 4 cos cube x minus 3 cos x. Okay, so 4 cos cube x minus 3 cos x, because I don't want higher power for my trigonometric function. So in the place of cos cube, I can rewrite this as plus 3 cos x equal to 4 cos cube x. So this is nothing but of cos 3x plus 3 cos x whole divided by 4 equal to cos cube x. So in the place of cos cube x, I can write cos 3x plus 3 cos x whole divided by 4 into dx. Now take this 1 by 4 outside, you will get cos 3x 3 cos x into dx. Now partially take this integration for each term, 3 cos x dx. Now this is actually 1 by 3 sin 3x, because coefficient of x is 3, plus 3 integral cos x gives me sin x. That's all. The last we can write plus c. If you multiply this and write, means you will get sin 3x by 12 plus 3 sin x plus c. Okay, so do this 10th problem as homework, integral sin cube x dx. Hint for this 10th problem is, I give you formula for sin 3x is actually 3 sin x minus 4 sin cube x. Okay.